the definition of the number e. Definition of the number e. Okay. The definition of number e comes from the exponential function a to the power of x. A to the power of x. If I want to find the derivative of that, by definition, we get this. Right? A to the power of x plus h minus a to the power of x over h. If I factor a to the power of x, I get a to the power of h minus 1, right, over h. Now, this part right here, okay, given that this is the function, that part right there represents, okay, f prime at 0, doesn't it? So replace that with 0. Don't you get exactly this? So this is right now f prime at x, okay? F prime at x. I have ax times by this part, a to the power of h minus 1 over h. And that's equivalent to f prime at 0. Meaning, so a to the power of x, that's some general base exponential function. Exponential function generally look like this. Okay, you guys agree? From grade 11. So the derivative of a to the power of x, I just figured out it was this. A to the power of x times by f prime at 0. Now the definition of e is this. Okay. If a to the power of h minus 1 over h, okay, if the slope here, essentially I'm saying the slope here, so this is referring to the slope at 0 right there. If that slope, okay, so if we choose the correct base, so that slope is 1, a is equal to e. I.e., in other words, limit h approaches 0, e to the power of h minus 1 over h is equal to 1. Okay, this is the definition of e. Okay, it's the base which makes the slope right at that point perfectly 1. So from that, I'm going to find the derivative of this, e to the power of x. Okay, so the derivative d over dx of e to the power of x, right, Jake, you know this? The derivative of e to the power of x, Jake?
Yeah, wouldn't that just be f of x?
Okay, look. You factor out e to the power of x. What is that going to equal to? Okay, what is that equal to?
E to the power of x times f of x.
What just happened? The derivative of e to the power of x is e to the power of x. Okay, you know what? E to the power of x is a very special function. So here's e to the power of x. E to the power of x turns out to be e is approximately 2.71, approximately. So if you graph e to the power of x, see this y value? So let's say you have 1 here. You get e, right? Guess what the slope is right there? Exactly e. At 2, guess what the slope's going to be right there? E squared. The y value, okay? The y value and the slope value perfectly matches every single point on the graph. So it's a very special graph, okay, with respect to rate of change. The y value is same as the rate of change. Okay, and it's also the simplest derivative. How can it get simpler than that, right? Differentiate e to the power of x doesn't change.